Welcome to Zowie Estimation in 2016. We have a couple little changes. You might have noticed that our website rules, macomb.so.org. Station number 1 is still the same when you get 100 grams of a substance into a cup. Remember, I pick usually a solo cup of some kind, 7, 8, or up to 28 grams. And of course, the substance inside is 100 grams. So they have to give us 100 grams, not counting the cup. The cup is extra. Station number 2, we used to have the parameters of 100 to 5,000 pennies, or whatever we put in there. And now it's 110,000. So it gives me more options for containers. So I can put in rice or something like that. Really difficult. Station 3, the parameters used to be 100 to 1,000 centimeters. In small boxes, like tin boxes, tape boxes. And now I can go up to almost including, not quite, it's not quite a Kleenex box by Kimberly Clark, the usual Kleenex brand. That's a little too large. That's like 2,200 centimeters. So the box is slightly smaller than that, but the acceptable amount. Instead of these small boxes, we used to have like pencil boxes, chalk boxes, things like that. On the area of station number 2, when you're practicing this, which this is all this is about. If you're going to get your students to well, get a medal in this event, you need to practice a couple hours a week. Because and one thing that's hardest to do here is getting a box not hard, but counting out the material for station number 2 can be difficult. But you should not be counting out 6,955 of anything. What you're going to do is measure out 100 of them and weigh them on a scale. It might be, for example, if I was to use rice, I would count out 100 grains of rice. It would not be easy, but it could be done. It's not that hard to do 100 grains of rice. 6,900, very difficult. So 100 grains of rice, I measure that, and maybe it's, just to give you an example, 17.8 grams for that first 100. On the other side, keep that right down this paper. Count another 100 out. This time it's 17.9. Side, write that down. 17.8, 17.9. Next one I count is 18.2. And one more time, and I get 17.6. And I'll divide by 4. I get a number of, say, 17.85. Is what I have now for 100 grains of rice. Now I pour it into my cup that I've already measured to see how much it weighs. Maybe the container that weighs 100 grams, for example. And I pour in rice, and then I put it on a scale, subtract out the 100. I have 622 grams. Divide that by 17.85, and you get how many hundreds of grains of rice you have. And was it hard to count 400 grains of rice? Yes, a little bit, but much easier than counting out 6,955. So do that same thing with any kind of pasta you might be using. The smaller the pasta, the more you want to use this method, because it's easier to then practice more with your students. Boxes, of course, are easy to find. You want to measure with your ruler, make sure it's under 2,000 cubic centimeters. Add it to them, have them practice using their fingers. They're going to not be able to write on. They can't bring any measuring tools into the competition, but they have naturally occurring wrinkles on their fingers. And maybe this, for them, this is 2 centimeters or 1 centimeter, and this is 3 centimeters, and that's 5 centimeters. You want to have one long one, from the tip of their little finger to the bottom of the span of their hand. Maybe that's 12 centimeters for them. You want to have that because you don't want to measure on the side of a box 1 centimeter, 2 centimeters, 3 centimeters, because you're off by a little bit each time. That adds up to a lot. If you make one measurement of 10 or 12 centimeters and use that, then go the rest of the way with the 1 or 2 centimeters that you decided they have on their hand or their side of their hand or the side of their finger, then that's much easier and much more accurate because you make 1 or 2 measurements instead of 6, 7, 8, or 9. And make sure they also know that they're going to do length times width times height. A lot of times I see students in the competition, and this is what they do. They measure, they get that written down. They measure, they write that down. They measure again, they write that down. What's wrong? They didn't do the height. It should be this, this, and this. That number there is a lot different from this one, and they're going to be off by 25, 35%, right? Just without even being off on the measurements, just off right off the bat. Okay, so make sure they know how to do all 3 measurements. On the scoring, this is difficult for some people, but it really is just a simple calculation on your calculator. If your students estimate 3,500 and the actual number is 4,000, divide their number by what the actual number should be, you get a number. Multiply that by 100, and you get your score. For example, if we did have 3,500, give it as an estimation, and it was 4,000, that would be 0.875 times 100, 87.5 would be the score, which is pretty decent. Even close to 90% is a decent score. Estimated higher, this is a little trickier. If the estimate was 5,000, it should have been 4,000. 5,000 divided by 4,000 is 1.25. You subtract 2. Don't ask me why, it's just the way it is. It's an absolute value thing. So 1.2 minus 2, 1.2 minus 1.25 minus 2 is 0.75, negative, if you're subtracting. And you multiply that by 100, you get negative 75 points. The minus sign goes away, and you get 75 points. Okay? It's an absolute value thing. So it's not that hard, it's just that, remember, it's not the same as when it's under. There's two different methods. And it's on this course, on the rule sheet, how to do that, explanation. On the bottom, we added on this year, that's why it's in dark. The two changes are in dark, and in addition to the notes. Students are allowed to handle and pick up the material at Station 1, that's the dry substance, and boxes at Station 3. They are allowed to touch but not pick up the boxes on Station 2. That's because I have boxes, whether they be round or square or rectangle or whatever. I have cellophane on top so they can see through them, and a rubber band around them. And if a student picks them up, imagine if this is a box with rice in it, and it just has rubber band cellophane on top so they can see it, and they pick it up and go like this, you know what's going to happen. It's all over the floor. So we had to have the first year, and since then we've had to not pick up the boxes at our Station number 2. Come on in. Okay. There's 3 stations. Station number 1 is the dry substance, and it can be anything from nuts and bolts, which I did have about 6, 7 years ago. And it was, I think, 7 nuts and bolts and 1 nut. That made 100 grams exactly. And most of the students didn't take them apart. They just put them all together. So I had lots of people with 92, and a lot of people scored 108, because the extra 8 grams was on there, or missing 8 grams. So that's okay. That was still a pretty good score either way. If you have, whatever you're over the top of on any of these, as long as you're not more than double, you're going to get a score of something. For example, if 100 grams is supposed to be given, you give us 35 grams, a very low score, but you still give us 35. If you give us 135 grams, you're going to get a score of 65, because it's 35 off from 100. But if you go to way upper top, like 200 or 201, your score is going to be what? 0, because you're more than double. So a low score, if you give us the cup not quite full, a little less than it's supposed to be, you get a score of something. And if it's 15, so you score 15. But 215, you score 0. Or anything more than 200 or more, you score 0. Questions about what if I have one student really good at one area and really good at the other? Then let them take charge of that part of the competition. So if you have 2 students and both of them are pretty good at Station 1, have them disagree, kind of not argue about it, but put some more in, take some out. Yeah, that's 100 grams. Okay, you give us the cup, we put it behind the partition so nobody can see it, and then they're done with Station number 1. They go on to Station number 2, and they work on that, and student number 1 is really good at Station number 2. He needs to really get accurate on the numbers on that. Student number 2, not so good. So don't let that person take charge. Say, Johnny, you're in charge on Station number 2, and Susie's going to just watch you do that one. And then on Station 3, Susie's really good at the cubic centimeter volume, and Johnny not so much. But then let her take charge on that part of it. Okay, so they don't have to both be good at both parts, all parts. Okay, there are 3 containers and 3 boxes. So there's 6 scores there. Then of course 100 grams. That's 7 different scores, each worth 100 points. Perfect score would be 700 if you were to do that. No one's ever done that. We've had, I think, the highest average score for all together. If you took the 7 scores they received, like 94%, it's been pretty much good, which is still pretty good. And so anything close to 90 will get you a medal of some kind, usually. This year might be a little lower because I'm going to probably give something a little more difficult. It's going to be harder when you go to from 5,000 to 10,000 objects. It would be a little, you could be off by a lot more. So the score might drop a little bit. Maybe this year 88% will be in the medal still. You don't know that for sure yet. We don't know. What happens on that day of the competition. Any questions about Station number 1, 2, 3, scoring? It is timed. It's a half an hour. And they generally have between 5, 6, 7 minutes on Station number 1. We don't tell them they have to leave, but there's only half an hour for all 3 stations.
All 3, not per.
Right. So it's like 7 or 8 minutes. So you could have more if you want. Then you're going to short yourself out on the other 2 stations. And those have a lot more to deal with. You know, just 3 boxes and with stuff inside of it, and 3 boxes that are being estimated for the volume. So you definitely have more time consumed over there. So the 100 grams is supposed to be pretty quick. Usually for most students, it's 1 or 2 minutes. And then off they go to Station 2. We don't hold everybody back. So as soon as that team is done and give us their cup, they can go to Station number 2. When they're done with Station number 2, they go to Station 3. You may come back to Station 2, because this does happen occasionally. We have a team that's working, and they're on station number 2, and they're doing length times width times height for the objects in the container. And then they go to station 3, start working on that. Length times width times height, and they go, wait a minute. We did length times width times height for objects. And then we say, can we go back to station 2? Yes, you can. Then someone else goes, can we get our cup back? And they say, no, you can't get your cup back. Once you turn that in, it's done. Because then you can talk to people, and they say, the cup should have been only half full, I'm sure of it. You know, and then I want to change my cups up. I put up with the cup. So, no, can't do that. But station 2 and 3 can come back and forth from that, not a problem. Yes?
About the timing for the station. So if it's 30
minutes
minutes,
total.
so average is like 10 minutes per station, right?
Yeah.
But
Could be.
can they spend more time and in one,
Yeah.
for example, like 9 minutes in one station, 11 minutes?
There's no time limit once you can spend as much time as you want on any station, but you have 30 minutes in total.
Okay.
When you hand us the cup, then you go to station 2, then to station 3, and you can spend as much time as you want at either station and go back and forth, just not back to station 1.
And what about partners doing 2 stations at the same time? So like one does the...
Probably not,
No.
because it's kind of crowded in there, and you have people flying back and forth, it'd be kind of crazy. If I had that happening for like 1 or 2 teams, yeah, no problem. If I allow that to happen and I have all 20 teams, it would be traffic jam. So if you do have a situation where one student is taking the lead, the other person just kind of sits back and watches, and they go to station 3, and then vice versa, that the other student takes control, and the one kind of watches on that situation. Yeah. So your boxes now, I think I mentioned that the Kleenex box is about the biggest you can get, a little bit smaller than that. Okay. So that does give us more options though for practicing, and that's the key to this event, is to practice. If you don't practice a couple hours a week, guaranteed not going to do that well. Yeah. It's just practicing and you get good at it. You just get good at estimating. Get 100 grams, maybe not M&Ms, but 100 grams of something, put it in a Ziploc baggie, give it to them to take with them after they're practicing with you, and have them put it in their pocket, and they walk around with it. Every once in a while, say, pull it out, 100 grams of pennies, 100 grams of whatever, paper clips, whatever it might be, 100 grams of erasers, and then put it back in their pocket. And then might take it out for a day or 2, and then take it back out again. Yeah, 100 grams, whatever you give them. Maybe give them 2 or 3 bags, Ziploc baggies. Maybe lentils, navy beans, kidney beans. That's a lot of those choices are good because they're not that expensive, and that's something that you can do. Especially for you, you only need 2 kids or whatever, unless you have an alternate team or something. But for me, I've got to get 15 pounds of the stuff. So even lentils can cost money after a while. But yeah. So, but paper clips, pennies, dimes, nickels, quarters. I will not use cornmeal. It says on here cornmeal, but I'll never use cornmeal again. I did that a long time ago, and we were all powdered before we walked out. And the floor was covered, and we had to take the vacuum out. And Macomb, South Campus was not happy with us, so not using cornmeal ever again. Any other questions?
Seems like there was no Scantron type of...
No Scantron. No, it's actually a piece of paper that they give them a piece of paper. They walk in, and they put their name on top of it with their team number. And they come to station 1. Their team number will have a couple have their team number on it. Their team 45. Give them cup 45. And they put what they want inside of it, hand it back to us. We measure it after they leave. So they turn the paper back into us with their numbers on it, and then we put on how much their cup weighed afterwards.
What exactly is station 2?
It means the number of objects in a container.
Okay.
So up to 10,000. Okay.
Thank you.
So the only 2 things they should be bringing in with them are a pencil and a calculator?
There'll be nothing with
Nothing.
them.
Okay,
I
it's all
provide
provided.
pencils and calculators. We had somebody one time complain that their calculator couldn't be used to measure. They were taking the calculator that they knew was 7.8 centimeters. They were taking it and putting it on the side of the box, like so. This is their calculator, and they said, why? My teacher said we could use the calculator to figure out the measurement. I said, yeah, you can punch numbers on the calculator. You can't take the calculator and go like this and figure out 7.8 times 5. That's a measuring device. Yeah. So, no, couldn't do that. And pencils as well, because we have had in the past where people have made marks on them, even teeth marks on them. They know from the point to the teeth marks are exactly 8 centimeters and stuff like that. So when you see someone take a pencil, you know, they say, well, how do you know? Well, it's not that hard. I see someone doing this with their pencil, and I know they're using the pencil to measure. It's not correct. That's cheating. So they've actually measured it beforehand. They use it as a measuring tool.
So they don't really need anything
You can
then?
use your fingers, yeah, but you also cannot take a pencil or a pen and make a dark mark on exactly where you know 3 centimeters are. So when we see people doing that, we look to see if they're just using the natural forming wrinkles in their hands, and that's fine. But no black, you can't put a black mark here, a black mark there. You know, that's 3 centimeters, thank you very much. It's estimation, it's not supposed to be actual. Yeah. Any other questions? Yes, no problem. I actually have people coming in with pencils and calculators, and they're handing it off to their coaches as they're walking in because we don't want anything to come in. There's no question as to what to use. It's always my pencils, my calculators. No one can say that it was somebody brought something in that was illegal. Yes?
The number of objects in a cylinder, like it's a round cylinder, is it?
I generally don't use that, but it would be what you would do if you, suppose I have done one time, I used a little aquarium. And they kind of rounded, they're kind of flat on 2 sides, and then round on the sides, ellipse. And you would treat that as a rectangular prism, and then you subtract a little bit off, is all you would do. You would not treat it as, how I figured that out, there's a formula for that somewhere, but you wouldn't do that. You just look at it as if you saw it being completely contained. And then you'd say, well, that's 90% would be what I would choose from the total amount that I'm seeing now, so you just take a little bit off. You would not try to figure out some formula for parabolas or something like that. It would not be something you can do for 3rd, 5th, and 6th graders. Yeah. But I generally do use rectangular prisms. The boxes are going to have the top will be open, and there'll be at least one side open. And there's labels on the front. It's the same for everybody. Now remember, you're not going to try and figure out some formula for length times width times height for the number of objects. You're going to count the surface, what you consider one layer, and then you're going to run the side. You're going to see, I just counted one layer. It's about that thick. How many layers do I see? And you use your calculator, and you're going to go, oh, I counted 139 across the top, and I know I see 11 layers. 139 times 11 is, boom, answer. It's really simple. So you teach them to count accurately in rows, or whatever way you want to teach them, so that they accurately count what they believe to be one layer of the surface. And then, how many layers do I see? And you find out how good they are because you're going to have, you know how many there are in there, and you're going to see how close they get with their layering, and then they're counting how many layers there are. Any other questions? Okay, practice makes perfect in this event for sure. So do that a lot, and I guarantee your students will at least do well. Okay, if you have any other questions that you didn't hear answered today, or if you come across something else, the website's available for you to pose a question, and I'll answer it as soon as I can. Okay, thank you.